In this video, we'll look at some examples that allow us to use derivation rules to write proof sequences. A proof sequence is a sequence of statements and reasons to justify an assertion of the form A implies C. So we always want to start with A as our given. And the proof sequence lists statements B1, B2, B3, and so on, as long as each new statement can be derived from a previous statement or statements using some derivation rule. And the sequence concludes with C. So let's look at an example. We want to write a proof sequence for the assertion P implies Q, and Q implies R, that those three statements imply R. So each of the three statements on the left is a given, and we'll list those first. And we want to look at what we're given and try to use one of those derivation rules to get a new statement. And my eye goes to statements 1 and 2. Given P and given P implies Q, I can use modus ponens to conclude Q. And so I'll write the statement. I need to make sure I'm calling it statement 4. I'll put the statement on the left and the reason, modus ponens, on the right. And I also need to indicate which two previous statements I've used for modus ponens. Now I need to use any of the 4 statements that I currently have to make a new conclusion. So I see that statement 4, I have Q, and in statement 3, I have Q implies R. So I can use modus ponens again to conclude R. And I indicate that I've used statements 4 and statement 3. Now this proof sequence is done because I've gotten R, and R is the conclusion that I was hoping to make. So you start with the givens on the left, use your derivation rules until you get the conclusion on the right. Let's look at another example. Write a proof sequence for the assertion P or Q and not P imply Q. So these two statements on the left are our givens, and we will start with those. And now we're looking to use any of the 10 derivation rules to get a new statement. So let's apply double negation to statement 1. P is logically equivalent to not P, so I can substitute not P in the place of P in statement 1. Next, I can use an implication. Anytime I want to take an or symbol to an if-then statement, implication is the rule to use. It's very useful. So implication, just following the rule that we wrote down earlier, gives me not P implies Q. And finally, I can use modus ponens with statement 4 and statement 2. Given not P and given not P implies Q, this allows me to conclude Q. And the proof sequence is done because I have the conclusion that I was hoping to make. These are less intuitive, and they will take some practice to be able to write the proof sequences, but it's very important that you know each of those 10 derivation rules by memory. Now you try. Write the proof sequence to prove a statement is logically equivalent to its contrapositive. So we've done this already using truth tables. I just want you to try it using a proof sequence to see if you can do it another way. And if you want to prove a logical equivalence, you actually have to write 2 proof sequences. This arrow goes in both directions. So you'll need a proof sequence starting with P implies Q and deducing not Q implies not P. And you'll need a proof sequence that starts with not Q implies not P, and deducing P implies Q. This will be a very good exercise for you to try on your own, and if you get stuck, the answer is on page 22 of your textbook.